Welcome. We often see computer vision as a black box that magically identifies objects in an image. But for those of us building, deploying, and relying on these systems, magic isn't a scalable strategy. Today, we're going to peel back the layers and move beyond the pixels into the core mechanisms that enable a machine to see. We won't just rehash the basics of a convolutional layer. Instead, we'll trace the evolution of thought, from the rigid logic of handcrafted features to the learned hierarchical representations of CNNs, and finally to the global context-aware reasoning of vision transformers. The goal here is to arm you with a deeper intuition. For engineers, this means understanding why a model fails. For architects, it's about choosing the right tool for the job. And for data scientists, it's about knowing what happens when you move beyond the model.fit command. Let's begin. Before deep learning dominated the landscape, we had to tell our algorithms exactly what to look for. This was the era of handcrafted feature descriptors. Think of algorithms like SIFT, Scale Invariant Feature Transform, or HOG, Histogram of Oriented Gradients. These weren't learning algorithms in the modern sense. They were brilliant, engineered pipelines based on human intuition about vision. For example, SIFT identifies key points in an image by finding locations that are stable across changes in scale and rotation, and then describes the neighborhood around each key point using local image gradients. It's essentially creating a robust numerical fingerprint for a patch of an image. This approach was powerful because it encoded our prior knowledge that corners and textured regions are important for recognition. However, its core limitation was its rigidity. These descriptors are brittle. They struggle with significant variations in lighting, occlusion, and viewpoint that weren't explicitly encoded in their design. This foundational understanding is critical, as the core idea, finding hierarchical features, is precisely what neural networks learn to automate. The paradigm shift came with convolutional neural networks. The genius of the CNN wasn't just in its performance, but in its philosophy. Stop telling the model what to look for and let it learn the features itself. This is where the real deep dive begins. A convolutional layer isn't just a filter, it's a trainable feature detector. In the initial layers of a network like ResNet, these filters learn to activate on primitive patterns. Oriented edges, color gradients, simple textures. Think of them as a massive, optimized bank of Gabor filters. As we move deeper, the magic happens. The second convolutional block doesn't see pixels anymore. It sees the output of the first block. Its input is a rich map of where the simple edges and gradients are.